Okay, so in this tutorial, we're going to be covering exactly how to make a PCB. So a PCB is a printed circuit board, and it's pretty much the so-called computer chips that people like to talk about. But the idea behind this is it's pretty much a plastic board with copper on the top, lining the top. And what you can pretty much do with this board is you can go ahead and solder up your components, and the copper you can actually trace and draw so it connects to your other parts that you want on this board. So instead of having to worry about, connecting all your wires up together and making this giant wire monstrosity, you can just pretty much solder your parts onto this board. Everything will be connected up, and it makes a very finished product. So it's great for your final device if you want to make something like this. And sometimes it's actually very beneficial to actually make a printed circuit board because some parts are actually surface mount only. So some very, very small parts, say like this, you have to make a printed circuit board for because otherwise it's impossible to go ahead and test these devices out. So with that, I think it's a very good idea to explain exactly how a PCB is made. So we're going to go ahead and refer to this website. This gives a good example of how a two-layer board is made. You can make this one with 4 layers of copper, 5 layers of copper, but 2 layers pretty much gives you a good insight of exactly how these things are made. So what you do is you get this piece of plastic called copper laminate. So it's plastic with a very, very thin sheet of copper on the top and on the bottom. And with this, what you pretty much do is you remove all the copper that you don't want. Through this technique called photolithography. So photolithography requires this thing called photoresist, which is a chemical that can do either one of two things depending on the photoresist chemical. So in one instance is if you expose the photoresist to UV light, what's going to happen is that it's going to actually solidify and harden up. Another case, what you do is if you expose to UV light, it's actually becomes soluble, so you can dissolve it in some sort of substance. Typically, it's a very strong base is what the people use. So the idea behind it is you pretty much cover, in this case, what they pretty much have is the photoresist that hardens up. So what they did was they pretty much covered everything that they want removed, and everything that they didn't want to remove, they exposed. So they expose this to UV light. What happens is the photoresist on the top coat that coats the copper is going to go ahead and harden up. And once it hardens up, that makes it so that it shields this copper from any sort of like damage. So what they pretty much do with this is they then afterwards expose this to some sort of oxidant that eats at copper. So typically it's ferric chloride. And once they have it exposed to ferric chloride, what happens is that all the copper that wasn't shielded by the photoresist gets removed off. And then you can later remove the photoresist using some other chemical process. So with that, you pretty much now have all your little thin copper wires that connect everything up together. But there's a problem with copper where it's very prone to oxidize, so it can rust very, very quickly. So what people do on top of this is they add this thing called solder mask or stop mask. And so the stop mask pretty much makes it so that it's less exposed to oxygen, so it doesn't rust. However, there's a problem where the exposed pads that you need to actually connect things up are still copper and they'll still oxidize. So what people do on top of this is they also layer it with some sort of metal that doesn't rust very quickly. So people typically use something like tin or like gold. And so once they have this all set up, you can actually just solder this board up and have it all up and running. But what people like to do on top of this is actually use a little printer and actually put a little description on the top just to make sure that everything's all up and organized, so you know exactly which part is which. So what people do is they add this thing called silkscreen, and the silkscreen is this white little ink that people put on top of the PCB. And that's pretty much exactly how a PCB is manufactured. In the case with a 2-layer board. For a 4-layer board, it's slightly different, but the idea is the exact same thing. So with that, the way to make these, we're not going to be making these by hand. What we're actually doing is we're going to be using the software that makes the files necessary to produce these, and we can send them off to a manufacturer so they can actually produce these PCBs. So we're going to use the software that we're using is called Diptrace. You can go ahead and download it here. So go to diptrace.com and go to downloads and go ahead and get the freeware. So the freeware, what it pretty much allows you to do is you get all the features you need, but there's 2 small limitations. So you can only do a 2-layer board, and you're allowed for only 300 holes on your PCB. The holes are important because what it does is it allows you to connect the top and the bottom layers of copper together. But with 300 pins, that's more than sufficient. And so we're going to be using that for our tutorial. Now, there's also this other software that I'd like you guys to be aware of. It's called EagleCAD. So EagleCAD, you can also get freeware for them as well, but there's one limitation, which is the fact that your PCB can only be of a set size. That's their one limitation. For the Diptrace, it's only 300 holes. But the thing is, there's quite a lot of tutorials for this. In fact, this is actually the first ECAD software that I learned to use, and I actually learned them through this thing called Tangent Tutorials. So if you go to tangentsoft.net/elec/movies, you can go ahead and find these tutorial series about how to use Eagle CAD. So starting from tutorial 7 all the way down to 14, you'll pretty much get a very holistic view of how to use all the things about Eagle that you'll actually ultimately need to use. So we're going to go ahead and get started with Diptrace. Okay, so with Diptrace, what we're going to be doing is we're going to be making an astable 555 timer circuit. So a 555 timer, or this little chip right here, is actually a very, very commonly used chip. In fact, if you go ahead and talk to one of the old electronics engineers and say 555 timer, it brings up quite a lot of history because these things are very, very useful. So the idea behind it is you have these 8 pins, and by organizing these 8 pins together, you can actually do a variety of things. So the astable circuit configuration, what this pretty much does, it creates a series of pulses. So you can actually output like frequency signals with this. And so the idea behind it is that you can actually adjust the frequency by adjusting the resistor and capacitor networks right here. And you can actually change the high time and the low time. So the high time is when it's actually switched high. So the high voltage is whatever voltage you put in, and the low time is this amount of time right here. And so you can go ahead and also adjust the duty cycle according to this formula, and the mark time as well. So this is another formula as well. And just by the organization of resistors and capacitors, you can create a variety of different frequencies. So with that in mind, we're going to go ahead and just copy the schematic, and then we're going to go ahead and put the schematic onto Diptrace, and then go ahead and make the actual PCB that can connect all these parts together. Now, before we begin, it's highly recommended you grab a 3-trigger mouse. This is one with the left click, the right click, and the middle scroll button, because a lot of the functionality relies on it. So and we're going to be using that for our tutorial. So go ahead and grab a 3-trigger mouse for this. So once you have that, go ahead and click Diptrace. Now there's 4 options that you can select. So one, schematic capture. This is the one we're going to be using, but just for your information, PCB layout is the one where you actually want to make the PCB. Component editor and pattern editor, these are to make custom parts, which we'll be discussing in a later tutorial. So let's go ahead and select schematic capture. Okay, so I haven't opened up all the options right here, but if I go to View, Toolbars, I can also open up the last one, which is Design Manager. So Design Manager is also important as well. So as you can see right here, these are just some of the top icons as examples. Right over here are all the little component libraries. So if you go ahead and click here, you can actually select different types of parts that you need to use. In this case, this is a list of capacitors. And if you scroll down here, you can actually see things called from like Western Digital. These are actual semiconductor companies, and they have their parts listed here. So if you want to use those parts, you can go ahead and find them here. So before we even begin, we're going to go ahead and explain a little bit more about this interface. I'm sorry, let me go ahead and just hit escape. So the middle right here is actually where you want to put your parts down. This is where you actually draw your schematic up. And over here are just properties of your parts. So every time you list a part down, it's going to be listed in Design Manager, and it's going to give you a little bit of information about each one. So with that in mind, you might also notice that this is a white background. Typically, by default, it's a black background. But so what I did was I went to View, I hit Colors, and I selected white background. You can do the black background if you want, and you can also, by default, you can also select any sort of like random background color you want. But if you go to user defined, and you go ahead and select which color you want, so you can go ahead and, if you want, select this turquoise color, and it'll become turquoise. But I'm going to go ahead and go back to white because I like the white background. Okay. And another thing, you can see these little tick marks. So these tick marks are grid dots. If you want to remove them, you can go ahead and hit function 11, so F11, to remove them. But I like to keep them on because it's a good idea of exactly the general size of the part on this little piece of on this space here. So with that, we're going to go ahead and first find the 555 timer part. So instead of actually going through all these like little libraries and finding each one, we can go ahead and instead go to Filter, and the filter will go ahead and find the part that we want. So if we go ahead and change the search area to all libraries and type in our 555 timer part, in this case the typical name for it is the LM555, I'm going to go ahead and hit Apply Filter, and let's go ahead and do the search. So this takes a while, but it's a lot nicer to do instead of actually like hunting for the actual part, especially when you have a larger library. Okay, so it's done. And what you can see right here, let me go ahead and just close this. If I go ahead and click on these, you can actually see all the parts. So what you'll see on the top right here is what's going to look like on the schematic, and on the bottom right here is what it's going to look like on the PCB. So I can see right this one, for example, on the PCB version, it's going to be this weird circular shape. But we want to go ahead and have the dual inline package version, so that's the DIP 8. So we're going to go ahead and click this one. And once you have that, you can now have the highlight over your mouse cursor, and you can go ahead and select any place you want to put it down. And to put it down, press left click. And if you want, you can go ahead and put more and more down by pressing left click more and more. If you want to go ahead and stop pressing stop, actually put the component down, hit the escape button. So hit escape, and that'll make it so that you'll stop putting your part down. And if you want to go ahead and delete, just hit right click and go ahead and hit delete. Or if you want, you can go ahead and just if it's on your Windows computer, you can also press the delete button if you need to. Alright, so once we have this part down, there's a few things you can do to actually move around this space. So if you get the middle scroll button, you can actually scroll up and scroll down with it. And if you actually press down a middle trigger, you can actually pan around if you need to. And then there's also this button right here that if you want, you can zoom in a selected area. So all you just have to do is left click and select the area that I want to zoom on. So I'm going to zoom in on over here, and I'll just zoom in here. I'm going to go ahead and scroll out now. And this one is also the undo zoom button if you want to. There's also the undo option right here as well. Okay, so with that, we now need our resistor components and our capacitor components that are connected to this. So I'm going to go ahead and find the resistors first. So in this case, the library is going to be discrete. And you can go ahead and find here one part called a resistor, or res. As you can see, there's a variety of resistor sizes. So this one's like resistor 700. We're going to go ahead and just use a typical one. So this is just a typical resistor. You go ahead and click it, and then now you can actually place the resistor down. Another thing you can keep in mind is you press the space bar while you're doing this. You can actually rotate it 90 degrees if you need to. So I'm going to go ahead and press space bar to rotate it 90 degrees and put it over here. And then we need a second one as well, which is pretty much close to it. So I'm going to go ahead and just put it right here as well. And that should be all the resistors that we need right now. So I'm going to go ahead and hit escape. Another thing to keep in mind is that you can also change the grid size for this. So if you want to make the grid dots larger, you can go ahead and select over here, 0.3, and it'll make the dots a little bit farther apart. But I'm going to go ahead and go to 0.2 just by default. And with that in mind, we now need to put wires to connect this. So one end of this resistor needs to connect to pin 7 of the 555 timer, and another one of this as well. So I'm going to go ahead and select over here this button called Place Wire. And once you actually highlight over the space, it's going to change a different color. In this case, it's going to be red. Maybe if it's black, it's typically like yellowish or some other color. So go ahead, once it's highlighted, press a click, do a left click, and then you can go ahead and create a wire. So it'll go ahead and map to the closest point in time. So I'm going to go ahead and put it over here. And once it highlights red, that means it's going to connect to it if I press a left click. So once it's highlighted, I'm going to go ahead and hit left click. And now it's connected to this resistor component. And actually, if I put my cursor over it, you can actually see it's highlighted. So you now know that pin 7 is now connected to one of the ends of resistor 2. And I'm going to go ahead and do with the other one as well. Another thing to keep in mind is that you actually don't need to click this. You can go ahead and go to default mode. So if you hit default mode right here, you can actually just click one of the ends and it'll go ahead and initiate to do a wire connection. So that's by default what it did. Another thing to keep in mind is that if you want to go ahead and go back to default mode for all cases, you can go ahead and hit escape. So hitting escape will automatically set you back to default mode. And default mode just pretty much allows you to scroll scroll around and click on things if you need to. There's also a few other options you can do when you right-click a part. So I'm going to go ahead and just do, for example, this one. So you can go ahead and actually change the name. So you can go in the top right here. You can call it something else, like I'm going to say resistor. And it'll become, the name will be called resistor. But I'm just going to go ahead and just switch it back to R1. If you want, there's a few other options as well. If you want, you can rotate again. You can go ahead and click here to rotate. If you want, you can also hit Control R to rotate back again. And also, if you want to, you can go ahead and go to Properties, and you can also add a few other measurements as well. You can go ahead and change the value, or set the value of the resistor. So say your resistor is 10K, you can go ahead and write that up. It helps to keep things a little bit organized. You hit OK, you'll see that on the side over here with Design Manager, it'll actually change R1 and say it's 10K. But for the sake of this, I'm going to go ahead and make this no value at all, just to make it so that you can go ahead and set whatever resistor value you want. Just to make that clear. Okay, with that, we now need our capacitors. So there's actually 3 capacitors. There's one that's connected to pin 5. There's one connected to the end of this resistor, and one that's polarized that's just connected to VCC and ground, just to ensure that your power supply is very smoothed out. So I'm going to go ahead and again go back to discrete and go ahead and find the part called capacitor. So again, there's a variety of different capacitor sizes you can see right here. But by default, we're going to go ahead and use the go-to one, which is this one, cap. So go ahead and click that. You'll go ahead and have the option of putting on capacitors. So I'm going to go ahead and put one right over here because it's connected to R2 by default. One of them is connected to R2. So it just makes it a lot easier to connect them up. And I'm going to go ahead and put one over here that's connected to the control voltage. Okay, as you can see, by changing the grid size, I've limited my ability to move around in certain directions. So I'm going to go ahead and make it a bit smaller, so do 0.1, so I actually have a little more precise measurement movements here and there. So I'm going to go ahead and now put it down right here. And the other one is typically a polarized capacitor, the one that connects to VCC and ground. So I'm going to go ahead and find the polarized capacitor over here. So if I go ahead and scroll down over here, there's one thing called pole cap. So that's the one for the polarized capacitor, typical electrolytic polarized capacitor. So I'm going to go ahead and select that, and now I have the option to put the polarized capacitor down. And this one is connected to VCC and ground. One of the ends connects to ground. Again, the one that doesn't have the positive sign is connected to ground, so I'm going to go ahead and put that right here. And that should be all of our capacitors that we need. So I'm going to go ahead and wire all this stuff up. So again, you can go ahead and just select one end and connect the wire up to the other one. So that goes ahead and connects R2 to C1, which is the one that you can actually adjust and change the capacitor value to change the frequency of the output. Alright, and then the ground is connected to this other capacitor. This one is connected to VCC, so I'm going to go ahead and just wrap this around and connect it to VCC. And then this top resistor is connected to VCC as well, so I'm going to go ahead and do that. And then this control voltage needs to be connected to the capacitor. This needs to be connected to ground. So right here, and then connects to ground. And as you can see, it didn't do a really good job with connecting it to ground. So what you can actually do is go to the default mode, and you can actually click on the wire and adjust its shape. So if you click it, you can go ahead and hold left click and go ahead and adjust where all the wire is positioned. And also, if you need to, what you can also do is you can right click and you can actually delete the wire if you need to. So that's another way of doing it as well. And in fact, what I should be doing is actually moving this a little bit more out so this end pin right here can actually be connected to ground. So I'm going to go ahead and do that. So I'm going to go ahead and go to default mode, click on it, and actually hold down and actually move it around if I need to. I'm going to do that so I have some more space. And go ahead and go to place wire. I'm going to hit the ground and then connect this to ground. So I'm going to go ahead and do that. There we go. And that should be good enough. Okay, and another thing to keep in mind is that the middle pin right here is connected. Yeah, the middle pin right here is connected to pin 6. I'm going to go ahead and hit place wire, select this, and connect this to pin 6. Pin 2 is connected to pin 6 as well, so I'm going to go ahead and do that as well. And this is connected to ground, so I'm going to go ahead and connect this to ground. And then this one called reset should be connected to power by default. You can go ahead and connect that to VCC. And this one right here. And I think, yeah, that's pretty much it. But one thing that you also need to do is you also want to have some extra exposed pads that you can connect wires to connect it to the power, the ground, and the output. So what we want to do now is we want to go ahead and go to the library called con headers. These are connector headers, and they provide you, as you can see on the PCB layout right here, little exposed pads that you can go ahead and connect wires to. This one in particular is the male header version, but we want to go ahead and find the female header and the one that has 3 pins. As you can see, they have a variety of different sizes. If you just scroll down, you can go ahead and pick whatever you want. But if you go down to the bottom right here, this provides the female header versions. It doesn't really matter which one in particular. It just makes the schematic look prettier, that's all. So I'm going to go ahead and select this one with 3 pins and go ahead and put this one down. So I'm going to go ahead and hit rotate, so I press a space bar so I can actually connect these ends right here and make it closer to the rest of my circuit over here. So I'm going to go ahead and hit escape. One of these pins needs to be connected to the output, so the output is the one that gives out the frequency pulse. And go ahead and click this and just move it around, be kind of smart with it, and make it so that it connects to pin 1. As you can see, it tried to actually make it so that it's set to the best possible way so it's less confusing. And we want one of these to be connected to power, so VCC over here. So I'm going to go ahead and select this pin 3 is going to be connected to power. And then we want this one to be connected to ground, so let's go ahead and connect this one to ground. Whoops. And as you can see, it tried its best to find the best way to set the wire up so that's the least confusing. And as you can see, this is pretty much it. There's one thing that we might want to also add as well is to the output we want to connect this to an LED. So when the output is pulsing, you can actually see the LED flicker. But that is only in the case when the LED. That's only in the case when the frequency is very, very slow. If it flickers on too quickly, your eyes won't be able to catch it. But it's just good to have anyways, just to double check if this entire circuit is working. So we're going to go ahead and add an LED to this. Before that, we're going to go ahead and add a resistor in front so we don't actually overpower the LED with the pulsing signal. So go ahead and go to discrete, go to the default resistor, and we're going to go ahead and put a resistor, we'll just put it over here. And then we'll go ahead and find the LED button option right here. So LED is right here. So this is an LED, and I can go ahead and put the LED down here. And we're going to go ahead and connect this up so the end of one resistor connects to the output. So go ahead and place the wire, connect this to output. I don't know why I did that, but somehow that was apparently the best way to do it. And go ahead and connect this to the LED, and this one connects to ground. Okay, so we seem to have set this all up. It might be a lot better if maybe this is actually rotated, so it looks a little more organized, and I just move it about like this, and then I can move this and adjust it accordingly. So that might be a little bit more reasonable. Whoops. Right, gonna go ahead and go to mouse. There we go. So this might be a little bit more organized, but as you can clearly tell, this is actually a wire monstrosity. It's very hard to tell whether or not I actually connected everything up correctly. In fact, I'm not quite too certain myself. So we're going to go ahead in the next tutorial figure out exactly what's the best way to put this all up so it's actually very, very organized and you don't actually mess up. Because again, right now I'm not even too certain myself if I actually connected all this stuff up correctly.